Hi, welcome back to Academic Market Insights. I'm Dr. Russell Rhodes, joined by Dr. Larissa Adamiec. We're going to get in the weeds today. In fact, we went through how I'm supposed to introduce this a couple of times to make sure I say it correctly. But we're going to take a look at covariance and variance using historical data, which really is the basis of a lot of the different risk management techniques that we have to use. We've talked a little bit on here about Monte Carlo simulation. You have to have some of those figures sometimes to run simulations like that. So with that, I'm going to hand things off to Dr. Adamiec. She's going to show us how to calculate these using Excel.
Yeah, and we are actually going to dig a little bit one step further and look at the value at risk using this methodology.
Mm-hmm.
One of the things, and we will create another video about this, is the instability of the covariance matrix.
Mm-hmm.
And that's what makes this technique a little more dicey, so to speak, because Dr. Rowe and I have worked in the markets long enough to say that the markets are dynamic. They are constantly changing, which means the relationships between those assets are going to be changing as well. So keep that as a grain of salt for when we're looking at this. And it's one of the reasons why Monte Carlo simulations are sometimes preferred because it allows for the instability of those covariance, those relationships. Okay, with that, and today's session is all about doing this in Excel. So without further ado, we're going to jump into Excel. And today, because we're looking at a covariance matrix, we're going to be looking at more than one asset. Yay. Okay, first thing we always do, always, 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 right? Favorite thing to do, calculate returns. We're going to use percent returns. Oops. Today's price minus yesterday's price divided by yesterday's price. Cross. We're going to use 4 assets today: SPX, NDX, RTY, and VIX. Dr. Rowe, do you know what those tickers stand for?
Yes, the S&P 500, which is what all professionals consider the overall stock market, not the Dow Jones Industrial Average. I have to fight that one every year. The NASDAQ 100, very tech heavy, and the Russell 2000, which is basically small cap stocks in the US. And then finally, VIX, which is the 30-day anticipated volatility of the S&P 500 and has an inverse relationship with those other 3 markets. And that's what's going to make this fun.
It will make it fun. Okay, so now we're going to create a little table over here, and we're going to include the names. First thing we're going to do is create a weight row. Then we're going to have our mean. We don't really need standard deviation, but out of habit, I just can't not calculate it. So for today's example, we are going to use a equally weighted portfolio, which means that each of the portfolios really, it should be 1 divided by 4, and 4 being the number of assets.
And can I pop in for just a second? Because if you were doing 3 assets and you were doing equal, you should do 1/3
Yes.
instead of 0.33. And I actually just graded a homework this morning where some people just used 0.33 for 1/3. And they got, I mean, their difference was about 0.5%. Their answer was about 0.5% different. So,
Wow.
you said you could do 1/4 for each of those. The 0.25 is fine, but if you start doing something like thirds or sixths or whatever that
Right.
don't that have those numbers that go out forever, use the fraction. I know we forget fractions after grade school, but use the fraction.
Well, and especially if you're using it in Excel.
Mm-hmm. Oh, absolutely, absolutely.
So it's for this, it's
It's
nice.
very simple, but I just I came across that one a handful, I don't know, 4 or 5 out of 100 papers, and thought it was interesting.
Again, this is an unnecessary step, but I just can't help myself.
We want to have our standard deviation there.
and it makes the table look a little bit nicer, right? Now, the next thing we're going to do is calculate our covariance table. And I'm using a Mac, so it's under data, data analysis, and I'm going to grab covariance. I'm going to hit OK. And isn't it nice, Dr. Rowe, that this is calculated for us? Oops.
They give it to us as long as you don't go too far out.
Yeah. As long as you put it in the correct spots. And I'm actually going to redo this because I want to include the labels. I don't think I did.
I don't think you did either.
And you don't have to include the labels. I like to because it makes your life a little bit easier. Again, I like to put it right in the worksheet itself. I don't like to Excel automatically defaults to to creating a worksheet for you.
It puts it on another page. Excuse me.
So now we have our covariance matrix, and what we're going to see is that it's going to be half full. So we need to go ahead and populate this. And I don't know a very easy way to do this, but so I just manually do it. And this is not so bad with a 4 asset. It becomes much more tedious with a 50. So Russell with the SPX, Russell with the NDX, VIX with SPX, VIX with NASDAQ, VIX with RTY. Okay. Covariance matrix. Woohoo! Now, we are going to pretend you have had 3 semesters of calculus, 1 semester of differential equation, and 1 semester of linear algebra to make all of this what we're going to do next.
Yep.
Well, in one more step. First, we have to do portfolio return. And this again is our weighted average. So we're just going to manually type these in. You can do it with an array. There's an array function that allows you to do this quickly. But I really want to hone in that this is a weighted average. Next, we're going to do our portfolio variance, not value at risk. So it's a small r. Now we're going to say our multiplication. So we're multiplying 2 arrays. But we're going to multiply again. So we're going to have an inverse. And this really becomes the weight times the covariance matrix times the transpose of the weights. And that's what allows for the linear algebra to multiply through so that we can find the covariance or the portfolio variance of the portfolio. And again, that's why we're saying we're assuming that you have had all of this math. I got my 4 assets. And now my second array, and I'm going to use the covariance matrix. And then I said the transpose. And so we're going to transpose our weights. That should be all of the parentheses. Let me double check to make sure I've got it. Transpose. Oh, one more. Okay. Oops.
I don't think you needed that last one.
Is that what it is?
Yeah.
Okay. There we go. Yeah. Thank you.
You were good first. You want to do formula text for everybody? Because those are pretty complex.
Yeah, let me do formula text for both of them. Thank you.
No problem. I just, whoever taught me how to do that, I wish I could remember which one, but very helpful.
Yes. So now we're taking the
now you have portfolio standard deviation too.
Formula text. It's just simply the square root. Now we need a z-score. So the z-score you can find from a table, or you can use Excel's function. We're just going to manually type it in. I really believe that it's important to have at least the 2 and 3 standard deviation moves. So a standard deviation is negative 2.33. A 2 standard deviation is negative 1.96. And they just come up so naturally
They're
when we're
just
doing
you
things in
can get
risk
them from a
management.
table. They're like
Right.
hard-coded numbers for, yeah.
Mhm. So now we're going to look at our time, and we're going to say 1 day. This becomes the square root of 1. Dr. Rowe, what's the square root of 1?
1.
Yay!
Yeah. Do you love when you ask that in the classroom and everybody pauses because they think you're tricking them?
I know.
I don't ask trick questions.
No. So now we've got value at risk. And it shockingly becomes pretty easy. We've got the standard deviation times their z-score times their time. And we're looking at a 1 day loss of 3.2%.
That is a 1 day value at risk. What's the percentage?
99 at the 99th percentile, or
It's the
1
99
percentile.
percentile. So 1 out of 100 days, we expect to lose 3.2% or more.
And the reason why it's not that bad, because
Mm.
we've done other value at risk and we've been discussing this. The reason why it's not that bad is simply because of this VIX,
That
because it's
inverse
inversely
relationship.
relation.
Yeah, you can
Mhm.
see a lot of negatives on there with VIX.
Which means
Um,
portfolio diversification.
yeah. Oh. And unfortunately, before I get nasty little notes of people telling me that I don't understand VIX, we are aware that you can't invest in VIX.
Mhm.
It's not an investable product, but it is a great index to use when you're trying to show diversification, et cetera, because of the inverse relationship there. I think just because you and I have an affinity for VIX, we use it. A lot of people use bonds instead of a VIX return, with that assumption that it's an inverse relationship. But it's not that significant anyway, because bonds don't move enough. VIX makes it more exciting.
It does make it more
Yeah.
exciting. And
VIX
we
makes
hope you
everything.
found And we hope you found this video exciting. And if you liked it, please hit like. And if you haven't, hit subscribe. And if you are thinking, man, I wish you would go deeper into some topic, please let us know and put it in the comments. We will put out a video on covariance because, again, it's really important to understand why this is not stable. And it's something we look forward to discussing with you next time.